We want to solve the following equation. Z squared plus 2z plus 2 equals 0, showing all working. So for 3 marks, we can't just put that in the calculator. So let's use the quadratic formula. So z is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now here b is 2, so that's going to be negative 2 plus or minus, so that's going to be 4. Take away 4 lots of 1 times 2 all over 2 times 1. So that's negative 2 plus or minus the square root of 4 minus 8 over 2, which is negative 2 plus or minus the square root of negative 4 over 2, which is negative 2 plus or minus 2i over 2, which gives us negative 1 plus or minus I. We want to factorize x cubed plus 2x squared minus 3x minus 10 into 3 factors. 1 mark, and that means, of course, that we can just simply use the calculator. So let's just clear everything, and then we want a transformation, and we want to factor x cubed plus 2x squared minus 3x minus 10. If we do that, we get one factor which is linear and a quadratic. And that means this quadratic doesn't factorize. Now the question was about complex numbers to start with in part A, so maybe that gives us a clue that we should be in complex mode. And if we do that, we get x minus 2, x plus 2 plus I, and x plus 2 minus I. So x minus 2, x plus 2 plus I, and x plus 2 minus I. And then we do have 3 factors. Hence solve the equation. So x minus 2. Now we know that this gives us x equals 2. So this one here, we want to write it as minus negative 2 take away I. Just think about that. If you re-expand that, you get plus 2 plus I. And then this one, x minus negative 2 plus I. So that gives us x equals 2, negative 2 take I, and negative 2 plus I. A quadratic equation with real coefficients has one of the roots equal to 1 plus root 3i. Determine the quadratic equation. Now, roots of polynomial equations with real coefficients always have their complex roots in conjugate pairs. So straight away 1 minus root 3i must be the other root. So x take away 1 plus root 3i, x take away 1 minus root 3i equals 0 must be the equation. So let's expand out. We get x squared. Take away x into 1 plus root 3i. Take away x into 1 minus root 3i. Plus 1 plus root 3i. 1 minus root 3i equals 0. So if we look at this, so x times plus root 3i, x times minus root 3i, those are going to cancel. And so we get minus x, so that's minus 2x. And then if we expand this, we're going to get 1. And then here we'll get minus I squared times 3. So that's going to end up being 1 plus 3, which is 4.